In this video, we're going to talk about how to calculate the average y value of a function. So let's say if we have a curve, and this is A, and let's say this is B. There is some point C which represents the average value of the function. And it turns out that the area of the rectangle form using the average y value is equal to the area under the curve. That is the area shaded in red. To calculate the average y value of a function, it's going to be 1 over b minus a times the antiderivative from a to b, f of x dx. Another way you can see it, if you multiply both sides by b minus a, the area of the rectangle is equal to the area of the curve. The area of the rectangle is length times width. The length is basically the average y value. The width is the width of the interval, b minus a, and this is equal to the area under the curve, which is the antiderivative, f of x dx. Now let's calculate the average value for the function 2x minus 4 on the interval 1 to 5. So it's going to be 1 over b minus a, where a is 1, b is 5. So 1 over 5 minus 1 times the antiderivative, a to b, f of x, which is 2x minus 4, dx. Now 5 minus 1 is 4. And the antiderivative of 2x is 2x squared divided by 2. The antiderivative of 4 is 4x. Now this should be gone. We no longer need the integral sign once we take the antiderivative of the function. So now let's evaluate it from 1 to 5. So we can get rid of the 2. So this is going to be 5 squared minus 4 times 5 minus 1 squared minus 4 times 1. Now 5 squared, or 5 times 5, is 25. 4 times 5 is 20. 1 minus 4 is negative 3. And 25 minus 20 is 5. So we have 5 minus negative 3, which is the same as 5 plus 3. And 5 plus 3 is 8. 8 divided by 4 is 2. So the average y value of the function is 2. Now it turns out that for a linear function, a function that increases or decreases at a constant rate, the average y value is also equal to the average value of f of a plus f of b, if it's a linear function. If it's not, then this won't be the case. So let's average f of 1 and f of 5, and let's see if it's equal to 2. F of 1 is 2 times 1 minus 4, which is simply negative 2. F of 5, 2 times 5 is 10, minus 4 is 6. Negative 2 plus 6 is 4, and 4 divided by 2 is indeed 2. So as you can see, for a linear function, the average y value, or the average value of the function, is simply the average of f of a and f of b, if the function increases or decreases at a constant rate. Now going back to the original problem, f of x, which is equal to 2x minus 4 on the interval 1 to 5. Sometimes you might get a question like this. Find a c value where f of c is equal to f of, or the average y value. So how can you calculate the c value? where this expression is true. And that c value has to be between 1 and 5. So what you want to do is you want to replace f of x with the average y value, which is 2, and solve for x. So if we add 4 to both sides, 6 is equal to 2x. And if we divide both sides by 2, 6 divided by 2 is x. X is 3. So f of 3 is equal to 2. Therefore, c is equal to 3. C is the x value, where f of c is equal to the average y value of the function, which is 2. So that is it for that problem. Now let's try another problem. Let's say that f of x is equal to x squared. Calculate the average y value of the function from 1 to 4, and also find the c value where the average value of the function is equal to f of c. So let's begin. Let's calculate the average y value first. So it's 1 over b minus a, or 1 over 4 minus 1, antiderivative 1 to 4, x squared dx. So 4 minus 1 is 3. The antiderivative of x squared is x cubed divided by 3 from 1 to 4. So this is going to be 1/3, 4 cubed divided by 3 minus 1 to the 3rd divided by 3. Now what's 4 to the 3rd power? 4 cubed, which is 4 times 4 times 4, that's 64. So this is 64 divided by 3 minus 1 over 3, which is 64 minus 1 is 63. And 63 divided by 3 is 21. And 1/3 of 21 is 7. So therefore, the average y value is 7. So notice that in this case, the average y value of the function is not equal to the average of f of 1 and f of 4 divided by 2. The reason for this, the function doesn't have a constant slope. The slope of the function changes. This function is increasing at an increasing rate. So it turns out that because it's increasing at an increasing rate, the average y value of the function is going to be less than the average value of f of 1 and f of 4, or f of a and f of b. F of 1 is 1 squared, which is 1. F of 4 is 16. If you average 1 and 16, that's 17 over 2, you get 8.5. 7 is less than 8.5. So whenever you have a function that is increasing at an increasing rate, the average y value of the function is going to be less than the average value of f of a and f of b. Now there's one more thing that we need to do. Since the average value is equal to 7, we need to calculate f of c and find the c value. So we're going to replace f of x with 7 and solve for x. So therefore c is equal to potentially plus or minus radical 7. Now negative radical 7 is not in the interval, so therefore c is only positive radical 7. Let's try a decreasing function. Let's say that f of x is equal to 1 over x, and we want to find the average y value from 1 to 3. So it's going to be 1 over b minus a, antiderivative f of x dx. Now the antiderivative of 1 over x is ln x, and 3 minus 1 is 2. So this is going to be 1/2 ln 3 minus ln 1. ln 1 is equal to 0. So this is simply 1/2 natural log of 3. the decimal value of which is about 0.549. Now let's calculate the c value. So let's replace f of x with 1/2 ln 3. So solving for x, let's multiply both sides by 2x. On the left side, the 2's will cancel. So it's going to be x ln 3. On the right side, the x variables will cancel, and it's going to be 2. So x is 2 divided by ln 3, which, as a decimal, that is about 1.82, which is in the interval. So c is approximately 1.82. Now, for the function 1 over x, it's a decreasing function that looks like this. Let's compare the average y value of the function and the average of f of a and f of b. So let's average f of 1 and f of 3. F of 1 is basically 1 over 1. F of 3 is 1/3. 1 over 1 is the same as 3 over 3. And 3 over 3 plus 1 over 3 is 4 over 3. And if you divide that by 2, you're going to get 2/3, which is 0.67. So in this case, the average value is still less than the average of f of a and f of b in the interval. Now let's see if there's some sort of commonality. In the first example, where we use x squared, we had a function that was increasing and concave up. And the average value was less than the average of, let's say, I'm just going to write it this way, a and b. In the second example, we had a decreasing function, but even though this function is decreasing, it's still concave up. And the average value was still, I wrote greater than, I meant to put less than. The average value was still less than f of a, the average between f of a and f of b. Let's try a function that's concave down. Let's try negative 2x squared. On the interval, let's say let's add a plus 4 to it, from 0 to 1. So the average value, it's going to be 1 over b minus a, which is 1 over 1 minus 0. Antiderivative 0 to 1, negative 2x squared plus 4 dx. So this is simply 1. We could just ignore that. The antiderivative of negative 2x squared is negative 2x to the third power divided by 3 and plus 4x. So if we plug in 1, it's going to be negative 2/3 plus 4 minus, if you plug in 0, everything is going to be 0. So what's negative 2/3 plus 4? That's going to be 3 and 1/3 as a mixed fraction, which is about 3.33. So that is the average value of the function. Now let's calculate the average of f of a and f of b. F of 1 plus, actually this should be f of 0 plus f of 1 divided by 2. F of 0 is going to be 4. F of 1 is negative 2 plus 4, which is 2. So this is 6 divided by 2, this is 3. So notice that this time, the average y value of the function is greater than the average of f of a and f of b. Here we have a function that looks like this. Let's graph the right side of the function. It's a downward parabola, but the right side looks like this. It's a decreasing function that is decreasing at an increasing rate. So it's concave down. Let's try this one. Let's say f of x is equal to the square root of x. And let's find the average value from 1 to 4. Now this time, we have a function that's increasing, but it's increasing at a decreasing rate, which means that it's still concave down. So do you think that the average value, will it be greater than, less than, or equal to the average of a and b divided by 2? So far, whenever the function is concave up in the interval, the average value appears to be less than the average of f of a and f of b. If the function has a constant slope, let's say if it's linear, it appears to be equal. And if the function is concave down, it appears to be greater than. But let's see if that's true in this case. In the last example, the function was decreasing and it was concave down, and the average value was greater than the average of f of a and f of b. Now we have an increasing function, but that's concave down as well. So let's see if it still holds true. Let's go ahead and calculate the average value. So this is going to be 1 over b minus a, antiderivative, a to b. Square root x is x to the 1/2 dx. So this is going to be 1 over 3, x to the 3 over 2 times 2 over 3. So when you add 1 to 1/2, that's 1/2 plus 1, which is 1 over 2 plus 2 over 2, and you're going to get 3 over 2. Now instead of dividing by 3 over 2, it's the same as multiplying by 2 over 3. So this is the antiderivative, evaluated from 1 to 4. So this is going to be, let's multiply 1/3 and 2/3 together. That's going to be 2 over 9 times 4 to the 3/2 minus 1 to the 3/2. So what is 4 to the 3/2? This is the same as 4 to the 1/2 raised to the 3rd. 4 to the 1/2 is the square root of 4, which is 2, and 2 to the 3rd power is 8. So this is 2 over 9 times 8. 1 raised to anything is simply 1. So 8 minus 1 is 7, and 2 times 7 is 14. So this is 14 over 9, which as a decimal, this is about 1.5 repeating, which if we round it, we could say it's about 1.56. So the average value is about 1.56. F of a, or f of 1, is 1. The square root of 1 is 1. And f of 4 is the square root of 4, which is 2. So if we average f of 1 and f of 4 together, this is going to be 3 over 2, which is 1.5. So notice that the average y value of the function is greater than the average of f of a and f of b. So let's make a summary of what we've learned. So whenever the function is linear, which means that the second derivative is 0, it's neither concave up or concave down. The first derivative is positive since this is an increasing function. It's just that the slope is constant, which means the second derivative is 0. In this situation, the average value is simply equal to the average of f of a and f of b, based on what we've seen. Now, whenever the function was concave up, or when the second derivative is positive, it turns out that the average value is less than the average of f of a and f of b. And when the function was concave down, or when the second derivative was negative, the average y value was greater than the average of f of a and f of b.